Hi, I'm Akhil. In this presentation, I'm going to talk about depth first search or DFS. So, these are the aspects we are going to go through in this presentation. So, the first topic is what is DFS? Depth first search is an algorithm for traversing or searching tree or graph data structures. The algorithm starts at the root node, selecting some arbitrary node as the root node in the case of graph, and explores as far as possible along each branch before backtracking. So the basic idea is to start from the root or any arbitrary node and mark the node and move to adjacent unmarked node and continue this loop until there is no unmarked adjacent node. Then backtrack and check for other unmarked nodes and traverse them. In this way, we can cover all nodes in the graph. In this context, the word backtrack means that when you are moving forward and there are no more nodes along the current path, you move backwards on the same path to find nodes to traverse. So next, I'm going to talk about how it works um, using an example graph. So consider this graph. Let's run a DFS algorithm on this graph. First, choose any node, let's say node A as our starting node. Also, we want to ensure that we keep track of where we came from as walk through our graph. For that, we will be using a stack data structure. Also, for every node that we visit, we will keep track of where we came from and use that to both backtrack when we need to and also as an easy way to keep track of path we are constructing through the graph. The moment we check node A, we will push it right on top of our stack. Also, we will mark it as visitor. Next, we will want to recursively visit every single node that is reachable from node A, just as it doesn't matter which node we start with, it doesn't really matter which neighboring vertex we visit next, just as long as the vertex is reachable and is one of the neighbors of A. For example, we could arbitrarily choose to visit node B next. We'll push that also to the stack. Again, we can choose any neighboring node from B. I'm going to choose C, also add it to the stack. At this point, we hit a dead end. There is nowhere else to visit. We have gone deep as we can in this path, so we will backtrack up to the previous parent node. Um, we again in B. Um, we can now go to D node. Similarly, go to E, then F. From F, we cannot go to any nodes further, so we backtrack from the path we came. E, um, A, we can go to G, which is visitor. In this way, we can cover all nodes in the graph. Next, we can talk about the algorithm of depth first search. This is the pseudocode of the DFS. So first we have to variables. Let n is equal to number of nodes in the graph, and g is equal to adjacency list representing graph. Visitor is a boolean array containing true or false at uh, index I depending on whether or not node I has been visited. In the beginning, all values of this array is false since we didn't visit any node. At the bottom, define a starting node is equal to 0, then call the first search function to begin the function. So in the function, we have one argument at which represent the current node we are at. Next, so this statement checks whether the node already visited. If yes, return, otherwise go to the next statement. Here we mark the node as visitor. To get all neighbors of the current node, we pull it out from the adjacent list, explore them by looping over them. In this way, we can go through all nodes in the tree. Next, complexity. The time complexity of the DFS algorithm is represented in the form O of v plus c, where v is the number of nodes and a is the number of edges. The stack which is used to maintain to keep track of the last visited nodes. In the worst case, the stack could take up to the size of all nodes in the graph. Hence, the space complexity is of v. Okay, thank you.